Okay, let's take a look at 2020.
Okay. 20, what?
Problem number 20.
Okay.
So, we have 4 parentheses x squared minus 8 parentheses equals 84. Okay? When you see this problem, what is your first instinct? Raise your hand. What is your first thing like, hey, I want to do this first? Great. You want to distribute the 4, right?
Yeah.
Why?
Because we're doing it.
To get rid of the parentheses, because what are we doing? Are we solving? Are we going across the border? Or are we simplifying?
Solving.
Well, by distributing, what are we doing? Are we going across the border when we distribute?
No, it's staying there.
So we are simplifying. Now, what type of operations are we using
Inverse.
when we simplify?
Or I don't know.
Slow down.
What's
Slow
on
down. What type of operations? What do you mean? Okay. Order of operations. So let's go through the order of operations. Who comes first in order of operations? Parentheses. So can I do anything on the inside of the parentheses?
No.
No. Then who comes? We go to the outside. Who comes after parentheses? Exponents. Are there any exponents on the outside? No. Then we go to multiplication. Do we have multiplication? Yeah. So since there wasn't any exponents, there wasn't any doing parentheses, we can do the multiplication here. Okay, we distribute. We get 4x squared minus 32 equals 84. Okay? Now the parentheses are gone. Where do we go from here? Matthew, what would we do next? Add 32. Okay? So I get 4x squared equals 116. Good? Then what? Divide by 4. 116 divided by 4 is 29.
Yeah.
And x squared equals 29. Is the x by itself?
No, okay.
No, how do we get rid of it?
We'll
Take the square root of both sides. We get x equals. What should we do right after we square root? What should we insert? The plus or minus. That needs to go in right after we take the square root. Well, what do we ask ourselves first when we see that 29?
Is it negative? Is it just
Square root. Okay, negative would be good. Is it a perfect square? Is 29 a perfect square? No. Then we ask what? Not a square root. Is there a perfect square that goes into it? Is there a perfect square that goes into 29? No. So that our final answer then is the square plus or minus the square root of 29.
Somehow I got 29 and a half.
Well, I don't know how you did that, Chief. Okay? So, good. Questions on what we did through here? Did everybody get this problem right? Besides
Yeah.
your weird mistake? Okay, good.
Oh, I think.
Now let's take a look at 23. We got 3 parentheses x minus 3 squared plus 2 equals 26. Okay? So we take a look at this. What's your first instinct? What do you want? What are you wanting to do? What is your mind saying? Oh, do this. Distribute. Right? So again, think about what are we trying to do when we distribute? Are we trying to solve? Or are we trying to simplify? We're trying to simplify. And what type of operations do we use when we simplify? Order! Order of operations. Who comes first in order of operations?
Parentheses.
Parentheses. So we look at the inside. Can I do anything on the inside?
No.
So I go to the outside.
Yeah.
Who comes next?
Exponent.
Oh, we have an exponent.
Yes.
Yeah, so how do we simplify using that exponent?
Guess we don't know how to.
We don't know how to yet.
Yeah.
We don't know how to distribute an exponent. Okay? We don't have that knowledge yet. So if I can't get rid of this exponent, can I distribute?
No.
No. Because before I can distribute, I gotta get rid of this or apply it. Okay? So we can't distribute. So how else might we get the parentheses, get rid of the parentheses? Polar?
But like the square root sign or whatever over the like everything but the equals 26.
Well, what you do to the left, you gotta do to the right.
Okay, then do it to both sides. I guess.
But then you have the square root of 3. X minus 3 plus 2, that's all in square. That doesn't help us.
I'm just saying. I'm just
Okay.
yes.
I just let you know, that's what's going to happen. Is that going to help? Does that look like it's going to help?
Well, when I get rid of that exponent, then you have one.
But then we have a square root on the 3, and then we have a square root on the 2,
Yeah, 26.
and the 26. We have a bunch of square roots.
Okay then.
Okay? It's just not going to work out that way. Okay?
Okay.
Drew?
Divide by 3.
Okay, so what's your goal there to divide by 3? What are you trying to do?
You get the 3 with
You're trying to get the parentheses by
the
itself. That's how we get rid of the parentheses. We have to get the parentheses by itself. Okay? So we have to remove everything from the outside of the parentheses. Who's on the outside of the parentheses? 3.
3.
The exponent of 2. And 2. Who has to go first? Plus 2 because of inverse operations, right?
Yeah.
So I subtract 2.
And 8.
We get 3 parentheses x minus 3 squared equals 24. Divided by 3 would come next because of inverse operations. We get x minus 3 squared equals 8. Do I have, is the parentheses by itself yet?
No, we have that sign now.
Now we can do what?
Add that. Where we
Take the square root.
Ah.
Because that cancels out this and that. Good? So now, is everything going to be gone on the outside of the parentheses?
Yes.
So is there any point in having the parentheses anymore?
No.
No. So now we get x minus 3. Well, now we got to take the square root of 8, right? What's the first question we ask ourselves?
Perfect square.
Is 8 a perfect square? No. Then we ask, is there a perfect square that goes in 8? Who goes in 8 as a perfect square? 4 times 2. So we have the square root of 4 times the square root of 2. Can I take the square root of 4? Yeah, what do I get? I get 2 times, what about the square root of 2? Can I do that? So 2 times the square root of 2. Now, hold up real quick. What are we supposed to insert right after we square root? Plus or minus. So the plus or minus needs to go here. Okay? I know. How many equations do we really have here now? 2. We have 2 equations. Based off this, what are our 2 equations? X minus 3 equals a positive 2 times the square root of 2. And then what's our other equation?
We got 3.
X minus 3 equals negative 2 square root of 2. Okay? Because as soon as we take the square root, we have two solutions. But we're not done quite yet. We still have to do what? Add 3 to both sides.
So how do you do that though?
Well,
Not like-
they're not like terms, so
Oh.
add 3. Add 3. Right? Because we can't combine these because they're not like radicals. So our two solutions are a positive 2 square root of 2 plus 3 and a negative square root of 2 times, or negative 2 times the square root of 2 plus 3. So it's really nice when they look like this. Do these guys look the same?
Yeah.
What's the difference?
Negative.
So you could really just write it as plus or minus 2 times the square root of 2 plus 3. Okay? You can write it out for both of these, or you can just write it out once. Okay? Would they look the same? Questions on that? So, what was the difference between these two problems?
One was a lot easier. One you could distribute, one you
Okay, one we could distribute, the other one we couldn't. Why could we distribute on this one? There was no exponent on the outside. But when there's an exponent on the outside, we have to isolate the parentheses using inverse operations. Isolate the parentheses using inverse operations. Okay? Does that make sense? Okay, let's take a look at 25. Okay? 22 through 27, what do you notice about these problems? They all have an exponent outside the parentheses, so what are you going to have to do? Get the parentheses by itself. Good. You might want to make note of that in your notes. All right. Here we go. And 25. We have parentheses, 4x minus 5, parentheses squared, equals 64. Okay? What do you notice about this problem? Drew?
there's exponent outside.
Okay. So can we distribute that exponent? So we have to do what? Square root. Get the parentheses by itself. I square root this side. I square root this side. What am I left with on the left side? 4x minus 5 equals, what's the square root of 64? Sid, what'd you say?
Plus or minus.
Plus or minus 8. Okay? So, how many equations do I have? 2. Tell you what are our 2 equations?
4x minus 5 equals +8.
Good, and?
And 4x minus 5 equals 50.
Beautiful. Again, this is a key point. As soon as you take the square root, that's when you're going to get your 2 numbers. You don't get your 2 numbers at the very end every time. It's as soon as you take the square root, that's when you get your 2 values. Okay? If you guys do the rest of this right here, can you do the 4x minus 5 for those values? You guys want to finish that or no? I think you guys can get that from there. Okay? Same thing for 27. Same thing for 26. Same thing for 24. All right? Questions? All right? Please hand. All right. So, skill 7-3. We're going to solve quadratic equations using quadratic formula. problem we have?
Was this like yesterday or this Friday?
Let's try solving this. Negative x squared minus 7x minus 6 equals 0. How might we solve this? What do you think? What would we do first? Palmer.
Plus 6.
Plus 6. Okay? So then I have negative x squared minus 7x equals 6. Now what? Ian? Add 7x to both sides? So I get negative woo! X squared equals a positive 7x plus 6.
What? Now this is where I don't know what
You just add you just switch the 6 and 7 next to it. Okay, no problem.
Now what?
No clue.
Minus x squared.
Divide by negative 1.
Okay.
So I get x squared equals negative 7x minus 6.
Do the square root sign.
Square root both sides?
Yeah. Yes.
What?
We get x equals the square root of negative 7x minus 6. Now what?
You can't do that. It's negative.
Well, it just depends on what x is.
Wait, could you divide that? Could you take? Now combine the two x values.
How?
Add 7 at, you can't now.
Can't you cancel out by making it exponent, and you cancel out the radical?
So square both sides?
No, because then that
No,
turns into
isn't
x.
that, I don't know.
That turns into x. This is getting good too.
Wait, could you divide by negative one?
So we divide by negative 1 on the inside?
Like up 3. When we did it.
Right here? Can we do that? Yeah, that's okay. That's fine. We haven't done anything we're not allowed to.
But now we can add 7 without, this is getting confusing.
Any ideas?
There's not a way to get the square root.
No,
Huh?
then that turns into x squared.
Do you want to give us the quadratic formula?
So my question is, can we solve this using just basic inverse operations?
No.
No. Why not? What's the reason?
Because you'll end up just keep going back and forth.
Why though?
Because when you try to get rid of the square roots on the side, that turns back into x squared. And when you get rid of that one turns
Because
back
you're
into
using inverse operations.
Okay. But why?
This is a quadratic equation.
Well, we solved quadratic equations yesterday.
Okay, well this is you.
But this is
all
formula.
these.
This one has an X.
What?
This one has an X inside the square root.
What was the form of equation we were solving yesterday?
ax
X
squared
squared dx or bx
x squared plus bx.
That's the type of equation we were solving yesterday?
No, plus c.
Ax squared plus c, right?
This is the ax squared plus b.
This right here is
X
ax squared
Plus bx.
plus bx plus c.
Aha.
What's different?
Add bx in
We have a bx. How many terms of x do we have in this problem? 2. So is there any way to combine those two terms?
now.
No. So can we use inverse operations?
Oh, no.
No.
So you're
For
gonna
this guy, for ax squared plus c, how many terms do we have of x?
No. 1.
1. We have 1x. So can we use inverse operations there? Yeah. Inverse here. But when we have 2 terms of x,
Or use order.
we're gonna
I don't know.
we're gonna have to use
Yeah.
quadratic formula.
quadratic formula.
Another
What?
Okay. So did you guys write all this down?
Yep.
See? Try to
Except
solve
for
it.
like the Do you want us to write down the ax squared plus c to inverse to that kind of stuff?
I want you to use ax squared plus c. I want you to say we can use inverse there. Ax squared plus bx plus c. We're going to have to use another method.
Oh.
There's multiple methods we can use for ax squared plus bx plus c. The first method today we're going to talk about is the quadratic formula. Okay? So for this example, what would you say about it? What did we learn from this
Unable
example?
to solve with inverse operations.
Good. Can't use inverse. And why can't we use inverse? What's the reason?
Because it's got two x's.
We've got two different types of x's.
Wait, okay, so the ax squared plus bx plus c, that's the quadratic formula?
We're going to have to use that. That's one method. There's other methods besides the quadratic formula. That's what we're talking about today. Okay? The quadratic formula is this. And this is very important to have written down. This is a topic that you will use in geometry and advanced algebra, trig. This is a very common formula. And it is as such. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over
Oh my goodness.
2a.
Is that negative b?
That is negative b, or the opposite of b.
Well, couldn't you add the a's together? Or no, it's a's together. Never mind.
Looks pretty intimidating, right?
Just a little.
Oh, we thought that about that one thing.
Which one?
That like,
So,
I don't know, the really long one, I can't remember what it was.
so the a one or one,
Yeah, like
two, and
something like
Point
that.
slope form, y2 minus
that
y1
I don't know if you
equals,
think I've heard
or
of
y minus y1 equals m times x minus x1.
Yeah.
I don't know.
That was pretty easy.
Okay. The quadratic formula will give you the solutions for any quadratic. Any quadratic. This formula works every time. It will work for guys like ax squared plus bx plus c. It will work for guys like ax squared plus c. You can use the quadratic formula on any type of quadratic. You may want to write that down.
Won't there be a problem though, because we only have one b?
Just patience. Patience. Okay? You're getting ahead of yourself. Okay? We'll get there. The quadratic formula will work on any type of quadratic. It will get you the solution. This is the most surefire method. Doesn't matter what type of quadratic. If you have fractions in it, if you have decimals in it,
On any
it
what?
will work on any type of quadratic equation. Okay? So, you take a look at this. What do you notice? What's in here? What's in this formula?
Two b's and two a's.
Two B's, two A's, and
C.
one C. Where would we get those? Where would we get A, B, and C from?
The problem.
The problem, the equation. Right? This formula is derived from the equation ax squared plus bx plus c equals 0. That's the quadratic equation. Ax squared plus bx plus c. Okay? So where are we we getting our b values?
From the BX.
From the coefficient of x. Where do we get our a value? The coefficient of x squared. Where do we get our c value?
Let's see.
The constant. The constant.
So
You take those numbers, plug them in.
Okay.
That's it.
It's gonna be really hard.
Okay? That's it. Now, key here. What is this equal to?
0.
Your equation has to be equal to 0 in order to use the formula. Okay? If your equation isn't equal to 0, and you start using the formula, you're not going to get the right answer
Like at the beginning.
at the beginning. Okay?
So will you always give us an equation that begins with, or?
Not always.
We'd have to make it equal 0?
You'd have to make it equal 0 sometimes.
Oh.
Okay? We'll work our problems like that later. Okay?
Yeah.
Questions so far? All right. Well, don't we have some unfinished business here?
Yeah.
What equation do we want to solve?
That one.
That one. Let's solve it. We have negative x squared minus 7x minus 6. It's equal to 0. Okay? So, can we use the quadratic formula on this equation right now?
Yes.
Why, Sid?
That's equal to 0.
Because it's equal to 0. So, we've got the green light. Systems are go. Okay? The first thing I want you to do is I want you to just say, hey, this is A, this is B, this is C. A equals, B equals, C equals. Okay? It's a great first step. It just helps you say, okay, I know who's supposed to go in for A, I know who's supposed to go in for B, I know who should go in for C. So, who is A? Negative 1. Good. Who is B? Negative 7. Who is C? Awesome, awesomes. Perfect. You got it. Okay? So now that you know who those are, now just plug them into the formula. Alright, x is equal to? So the first part says negative b, or opposite of b.
Should be 7. Positive.
It's going to be a positive 7. Right? Because the opposite of negative 7 is a positive 7. Good. Then comes plus or minus. The square root. Okay? We're going to substitute b in here. It's negative 7. Again, when we substitute, what do we put around it? Parentheses. So I put my square. Okay? What comes after b squared?
Negative 4.
Minus. How are 4, A, and C connected? Multiplication. So we're going to take 4 times, what's A?
Negative 1.
Times,
Negative 6.
good. And this is all over who?
Negative 1.
2 times negative 1.
Yeah.
Now what? We evaluate, right?
That's all.
We go and evaluate. Where do you think we're going to start?
Wait, wouldn't the exponent 2 and the square root thing cancel each other out?
No.
They went in this one?
Well, no. Because this guy right here is connected to this guy by subtraction. So it's not like you can take the square root of this and then do this. Okay? Can't do it because this guy right here is connected to other people by another operation. Okay? Where do we begin?
The bottom.
Who? Okay, we can do that. Where else can we start? The exponent. Start inside the radical and get that done first. That's the first key. Get the radical done. Yeah, you can do this right away. What's 2 times negative 1? Negative 2. So you can get that out of the way too. We have my 7 here. We got plus or minus. We got our square root. What's negative 7 squared?
49.
49. Who comes after the 49? Minus. I'm going to tell you guys right now, the place where most people get tripped up is this minus 4AC. Okay? You put your minus sign, you make sure this is a positive 4. Okay? You make sure this is a subtraction sign, make sure that's a positive 4. So I put my subtraction sign here. Now I got to do my 4 times negative 1 times negative 6.
21.
You guys agree with Palmer? Positive or negative 24?
Positive.
Positive. So it's 49 minus a positive 24. Okay? Question so far? We've got to finish the radical.
Yeah.
Okay? You have to finish the radical first.
Subtract that one.
What's 49 minus 24? 25. So I have 7 plus or minus the square root of 25 over negative 2. Can I simplify the radical?
Yes.
You bet. Is 25 a perfect square?
Yes.
What do we get?
5.
Plus or minus 5.
Yeah, see? But guess who's already out in front for us there?
7.
The plus or minus. They've already done that for us. 7 plus or minus 5 over negative 2. So how many solutions are we going to get? 2. So what do we have to do first?
No, I put the x equals.
Well, it's still kind of continued all the way over here.
Okay.
So you can if you want.
Add.
So it's like -5.
So do 7 minus 5. What's that? 2. 2 divided by negative 2.
Negative 1.
So negative 1 is one of the answers. And then 7 plus 5 divided by negative 2. We just found our 2 answers. How could you check? Plug them back in. Okay? So let's try it. I plug negative 1 back in here. Okay? Negative 1 squared. 1. Negative, the opposite of a positive 1. Negative 1. What is it? You want to consider this a negative 7?
Sure.
Sure.
So we change that to plus negative 7. Negative 7 times a negative 1. So plus 7 minus 6. Negative 7 plus, or negative 1 plus 7. 6 minus 6. So is negative 1 a solution? Same thing, you plug in negative 6. Okay? It's going to work out. So was that bad? Was it a little lengthy?
Yes.
Yeah, it was lengthy, but I guarantee you, it will get you the solution every time. Every time.
So let's say we have like a positive 30 on where the 0 is.
Uh-huh.
We subtract that by both sides and then it'd be the same place.
You would subtract, so that if this was 30, you subtract 30 over here.
On the, would there already be a constant there though?
Yeah, well then you would just combine the 30 and the negative 6, so you get negative 36.
Is there always a constant whether it's 0 or a whole number?
You have to have a value for A, B, and C no matter what. So if you had a problem like 6x squared plus 3 equals 0, what would be your B? 0. Okay?
Wait,
So,
so plug it
for everything else.
to the quadratic formula or the first one?
The solution,
Yeah.
I plugged it back into the equation that we were solved. Yeah.
Okay.
All right? Sid.
How would you get 49 minus 24? Short or big?
You added, you did the, what's it called?
Negative 7 squared is
Oh, yeah, okay.
49. 4 times negative 1 times negative 6 is. Just try one on your own. This is your homework, okay? There's one problem. X squared plus, crap. I believe it's 9x plus 16.
Plus crap? Okay.
Let me check.
I'm doing it all every time I get here.
Plus 14. So x squared plus 9x plus 4t equals 0. See if you can do that. We'll work more with this tomorrow. Okay?